Okay, class, we're going to look at some word problems and apply these 2x2 systems applications. Now, when you set up these equations, that's the biggest part of this, is to set them up correctly. And you can use any of the three methods to solve these equations. So I'm going to do all the methods. I'm going to do some with elimination, some with substitution, and then even use the Desmos calculator on these two, on one of these two. Show you how you can do them different ways. So just kind of reinforce some of the methods we've been doing. Okay, so let's look. The hardest thing to do about this is turning these sentences into equations. That's pretty much what we're doing. So let's look at what we've got here. So let's look at this first example, 15. The sum of two numbers is 53. All right, so let's make this sentence say something. All right, so if we look at sum, that means to add. All right, of two numbers is usually means equals. Okay. If twice the first number minus 3 times the second number is 26. So let's dissect that right there. So if twice the first number, so when you have twice, that means 2 times something. Okay. The first number minus, okay, subtraction, minus 3 times, okay, so multiply again. The second number is equals 26. Okay, find both numbers. All right, so I want to know what these two amazing numbers are. So let's declare them. Let's say x will be the first number. And I'll just use the number sign there. All right, and then y will be the second number. All right, so declare some variables so we know what we're working with. So we got two variables, x and y. All right, so let's set this thing up. First sentence, the sum of two numbers is 53. All right, so we're going to take the first number, add it to the second number, and that equals 53. Pretty easy. All right, second sentence is a little more difficult. If twice the first number, so 2 times x, minus 3 times the second number, so minus 3 times y, is equals 26. All right, and then we have our system correctly set up. All right, so with this one, I'm going to use substitution. So let's take top equation, x plus y equals 53. Now you could use elimination, you can graph it, but I'm going to show you all the different steps here, the different methods, like I said earlier. Okay, so I'm going to isolate y. Why not? So let's subtract x from both sides. All right, bring down the y, and then we get negative x plus 53. All right, then I'm going to take this expression that y equals and plug it into y in the equation we didn't use, right there. Okay, so when I write this out, it's going to be 2x minus 3 times, okay, negative x plus 53, so I put it in there. Okay, it's going to equal 26. All right, so what I'm going to have to do is distribute the negative 3 into both of these terms, and then combine like terms and solve for x. Okay, so we got 2x, negative 3 times negative x is a positive 3x, and then negative 3 times positive 53 is going to be a negative 159. All right, equals 26. Okay, combine 2x and 3x, we get 5x equals 26. All right, then let's add 159 to both sides. All right, divides out, bring out that 5x. All right, and then we get 26 and 159 make 185. All right, then we're going to divide the 5, and we are in business. 5's divide out, x equals 37. All right, so here we've already got part of our answer. We know x is 37. That one amazing number, the first amazing number is a 37. So let's go ahead and I wanted to keep that the same color, but it's not working correctly. There we go. 37. Boom. All right. Okay, so now we take that 37. Once the variable equals a number, we can substitute it into almost any x, all right, from the original equations there. So let's go ahead and put it into the top one. Looks the easiest. So what I'm going to do, I'm going to take this 37 and drop it right in here. All right, so we're going to have basically 37 plus y equals 53. All right, and all we got to do is solve for y. So we'll just subtract 37 on both sides. All right, then we're going to bring down this y. And then 53 minus 37 is 16. All right, and that'll be our answer right there. Okay, and then let's look at our next problem. All right, Boy Scouts. Boy Scouts are selling popcorn at the parade to raise money for their camping trip. Ethan sold 9 small bags and 2 large bags made $36.05. Jack sold 5 small bags and 7 large bags and made $48. Find the cost of a small and large bag of popcorn. All right, so our variables here, okay, so a common misconception is kids will make the variables Ethan and Jack. That's not what they're asking for. They want to know the cost of these small and big bags. So your variables are going to be the small and large bag. All right, so let's say x equals the small bag and y equals the large bag. All right, so again, now we're going to make equations out of the sentences. All right, so Ethan sold 9 small bags, so that's 9x, and 2 large bags, plus 2y, and he made $36.05. All right, now Jack sold 5 small bags, so 5 times x, plus 7 large bags. That equals $48. All right, so to find the cost of the bags, right, it's 9 times the cost of those bags, and then to get the total, you would add those two totals together. All right, so let me fix this y here. There we go. Okay, so this one, I'm going to use elimination. Why not? All right, get one of each for y'all. Okay, so with elimination, the whole idea is to get some variables to cancel out. So 9 and 5 and 2 and 7, I tend to like the smaller numbers. They both are, all the numbers are positive, all the coefficients. So one of my numbers I have to multiply by needs to be a negative. So I'm gonna eliminate the y's. So let's go ahead and do that. The LCM there would be 14. Okay, so that's the smallest number that both 2 and 7 divide into. All right, so 9 and 5 would be a bigger number. Let's stick with the smaller numbers. I like to anyway, but it can be done if you want to get rid of x's that badly. But let's do 14. So multiply this entire equation. The way to make that 2 of 14 is to multiply it by 7. All right, then if I look at the other y, that's 7, we'd have to multiply this entire equation by a 2. But since I need one of them to be opposite, either the 7 or the 2 needs to be a negative, I'll just make the 2 a negative. All right, so now we'll have a positive 14 and a negative 14, and that'll cancel out. That'll eliminate. All right, so let's go ahead and get these rewritten. Let's distribute this 7 into each term. 9 times 7x is 63x. Okay, 7 times 2y is going to be plus 14y. That's what we want. And then 3605 times 7 is going to be $252.35. All right. Now the bottom equation, negative 2 times negative 5x is going to be negative 10x. Negative 2 times 7 is going to be negative 14y. And then negative 2 times 48, it looks like a negative there, equals. All right, negative 2 times 48 is going to be negative 96. Okay, so now let's combine these. All right, so 63x minus 10x, that's going to be 53x. Y's cancel like we want, plus 14 minus 14. And that's going to equal 252.35 minus 96. All right, and that's going to be 156.35. All right, then we're going to divide the 53 to isolate x. Okay, should be 53x. Okay, those divide out, and we get x equal to our money here, $2.95. All right, so again, we got our X part. So I'm putting a dollar sign because these word problems need context. All right, so X is $2.95. So what is X? The small bag. All right. So now we're going to substitute this $2.95 into one of the equations. I'll do it into the bottom equations just for the heck of it. So we'll take this $2.95 and we'll put it in there. Why not? All right, so let's kind of break this apart so we're not confused. All right, so let's take that bottom equation. Yeah, change one. Let's do the top equation. Let's take this 295. Let's put in this one there. That one just right next to it. All right, so we got 9x plus 2y equals 3605. All right, so let's rewrite it, substituting that 295. So we got 9, and in parentheses, substitute the 2.95. All right, plus 2y equals 3605. Okay, so multiply the 9 into the 295. We're going to get 2655. Plus 2y equals 3605. All right, now I'm going to subtract the 2655 both sides. All right, those cancel. Bring that down. You get 2y equals almost 10, 9.5. All right, now divide the 2. And then we get y equal to dollar amount. 9.5 divided by 2 is going to be $4.75. And that'll be our large bag. And it makes sense, larger bags should cost more. So $4.75. All right, and there is our final answer. All right, let's put that where we can see it. Boom. Okay. All right, so let's look at this other one. Right here, Angelina has a collection of nickels and dimes worth $4.65. If she has 70 nickels and dimes, how many of each does she have? Okay, so the 70 is a total of those things. All right, so got to be careful with this. All right, so Angelina has a collection of nickels and dimes worth $4.65. All right, so what are we comparing? We're comparing nickels and dimes. So they want to know how much each of those does she have. So those are our variables. And let's go ahead and declare those. So x is going to equal my nickels. All right, and y will equal my dimes. Okay. So let's set these equations up. All right, so Angela has a collection of nickels and dimes worth $4.65. So add all your nickels plus all your dimes. All right, and that's going to equal $4.65. Now let's think about that. Does that make sense? Do I just add the number of nickels and dimes? No, they have a value to them. So what we got to do is figure out what is a nickel worth, right? So if you have 2 nickels, right, that is 10 cents. How do we figure that out? Well, because a nickel is 0.05 of a dollar, right? So if you add those up, then you get 10 cents. All right, so we got to put those things in there. So we have 2 times 0.05, that adds up to 0.10, which is our 10 cents. So these things need a weight on it. So we got to put the worth of the nickel, 0.05, and then the worth of the dime, see if I might not have enough room, is 0.1. I'll leave the 0 so you can see that it's 10 cents. All right, and add them together. So there we go. So don't forget those words because that's a common mistake. All right. Second sentence, if she has 70 nickels and dimes, how many does she each have? So we know the total the 70 nickels and dimes. So this one's straightforward. We don't need a monetary value. X plus Y equals 70 of those things. All right, so again, 70 is not a dollar amount. 465 was a dollar amount. Okay, so once you get past that, it is now correctly set up. All right, so now we're doing with decimals and stuff, and we can solve this if we really wanted to, substitution and elimination. But hey, let's go ahead and graph these things here, and I'll show you how to get the answer using Desmos in the website. Boom, so here it is. I have it queued up. All right, so in the first equation bar, I'm going to write my first equation in there. So we're going to use, I don't know why I have an alphabet. Boom. There we go. Oh, that's why. Okay, hide that. Okay, so let's put our first equation down. I forgot what I wrote. Oh, okay, it's the nickels and dime one. All right, so we're going to get 0.05. Go away. Point zero. Sorry, it's giving me so much problems. I'm using it in tablet mode. 0.5 x x plus 0.10 y, and it equals $4.65. All right. Then in the second equation bar, I put 2 in there, and I'm going to put in our other equation. So it's just x plus y. I'll have to figure out why that keeps popping up. Equals 70. Okay, hit enter. All right, so now we've got, this thing wants to pop up. Maybe I just need to like disable it somehow. I don't know, it's driving me nuts. Okay, so now we got to find where they intersect on this grid. So I'm just going to keep zooming out. Oh, that's why. Put an extra equal sign in there. There we go. Okay, so you didn't see all the graphs. Just keep zooming out until you see the intersection. And then if you press on that intersection, it will get you that coordinate. And then we got 47 and 23. So we got 47, X is our nickels, 23 is our dimes. And that's what I'm going to write into my equation, 47 and 23. So 47 nickels and 23 dimes. I wanted that to be written. All right, so there is our solution there. Okay, guys.